going to start by looking at the market overview. When we look at the professional versus the commercial world in audiovisual, professional, it's not a statement on whether somebody has great business ethics or they do sound business. What we mean at Belden is that you're going to originate the signal, the audio and the video. So television stations, somebody who's actually generating content to put out over the air. And we also have commercial. Commercial is anybody who reproduces or distributes the signal. And we say that quality may not be as important because they're not actually capturing it, they're just distributing that. But when we say that, we have two different kinds, fixed installations and staged events. And just a small sidebar, I like to point out that for the most part, AV has been predominantly staged events. I mean, think about it, guys. Talk about emerging technology. AV in and of itself, back when I was a kid, was temporary. I remember pushing the AV cart. That's actually what we called it in school. Push the AV cart down the hallway. It would have a film strip projector or a TV strapped to it. It wasn't a permanent part of the building. So fixed installations in boardrooms, auditoriums, classrooms, those are becoming part of the norm today. When we look at the markets, again, I would even offer that 13 years ago when I started at Belden, it was pretty well defined. The broadcast guys were in the studios, they were on the radio and television studios, and the commercial guys were education and boardrooms. But nowadays, those lines are getting blurred. I mean, look at the education space. With distance learning and different television instances on the campuses, we're putting in a lot of professional gear. Same thing in healthcare. Healthcare with distance diagnostics and everybody trying to do more with less, we're putting in full broadcast studios there. And on the other end of the spectrum, digital audio has allowed the audio engineers to run their signals on twisted pair. So these lines are getting blurred, and it's leading to a lot of confusion from the infrastructure standpoint out there. And let's look at why. I like to ask a question when I do this presentation live. If anybody knows when the first television broadcast was, I'll tell you I cheated. I went to Google. It was actually in 1926. Most of the answers I get are sometimes in 30s or 40s. And my point is, from the 30s, we'll just round up, really nothing's changed in audio and video distribution. I mean, it wasn't until the 90s that we really started looking at moving from analog to digital. And the digital conversion started, but I would offer to you that many of us didn't have our first HD or digital or flat screen television in the house so easily into the new millennia. And in 2000, we started looking at HDMI conversions and different things from the digital world. And then finally, in 2010, we had the launch of what we're going to talk about today. Both HDBaseT and AVB really started germinating in 2010. And really, this is just letting you know that it's really impacted the industry. In fact, if we look at the 5 biggest growth drivers, and this is defined by AV Communications, conferencing, collaboration. Anybody on this call has been to an Infocom recently? You've seen the teleconferencing, telepresence folks have taken over probably a third to half of the show floor. AV and IT integration. We're talking about consolidating a lot of our infrastructure. And that AV and IT integration is really driving a lot of this growth and a lot of the changes. Digital signage. Digital signage is expected to triple in the next 5 years. Even high definition and moving to that 16:9 format is impacting the industry and driving growth. How many people have seen the old CRTs taken out of a boardroom and replaced by flat screens? Those require a new infrastructure. Now, I'm not going to spend too much time on this slide. This just kind of to set the stage. If we're looking at just the commercial AV type stuff, just looking at the cables, connectors, and hardware, it's a pretty robust market, $500 million in just the United States alone, and 8% growth. I know we wouldn't have been patting ourselves on the back back in 2001, but that's a pretty robust market. The biggest one, like I said a few minutes ago, is the digital signage. It's expected to triple to $4.5 billion in 2016. And with that digital signage is infrastructure concerns. What kind of infrastructure do I need to support that? What kind of infrastructure can I eliminate to make my installation easier and less expensive? A lot of fun new options coming out from a digital signage standpoint. So we're going to start with audio-video bridging, okay, or most commonly referred to as AVB. Now, audio-video bridging is still emerging. I would offer to you that it is not fully baked. We've got some ways to go there, but I think it offers some of the most exciting advancements in the AV and IT integration on the market today. So let's look at just now. Pardon me, guys. It's my simplistic drawing of an application where we've got audio, video, lighting, line control, internet. Again, my point here is just to illustrate that each instance of a different item that you have to have a different cabling infrastructure or wireless infrastructure. Each time you have a different device, you've got to have a port on that controller to specifically address it. The different colors are different kinds of cabling. Now, trust me, I get the irony that I work for Belden. I'd love there to be tons of colors on here. I want to sell you a bunch of cables. But this is a difficult model to maintain, and as the AV and IT integration continue to mature, we're starting to question, I wonder if we could run that on Ethernet. And for those of you who've been around a long time, if you were in the AV world, or excuse me, in the IT world, you'll remember that we didn't always run Ethernet on Twisted Pair. Ethernet was originally a coax. And it was Ma Bell who came in and said, I bet you could run that on Twisted Pair. And we're doing the same thing in the audio world. Now, the audio world, you'll see here, embraced, I would say, the UTP 100-ohm cable for quite some time. You'll see several different iterations of products that use an Ethernet-like protocol. The problem is Ethernet was introduced to be open and a free standard. And my joke about standards is the best thing about standards is there are so many to choose from. So look at all the different standard audio Ethernet you have to protocols that you have to choose from here. A quote from one of the folks at Belden, Steve Lampin, said that you know, once you've wrapped enough proprietary licensing around each of these protocols, it's no longer free nor open. He even tells a story about one manufacturer who spent millions of dollars to design and implement a low latency software that was specifically not compatible with anyone else. So while we get the idea and we're utilizing a much friendlier infrastructure by utilizing the unshielded twisted pairs, we're not quite there with audio either. Now, just for comparison, we're looking here. This is a CobraNet example. Look how beautiful it is that we're running everything to that Ethernet switch. I don't have to have a separate port for each device. Okay, I could put them on the LAN cable, and off we go. I don't have to have a physical connection for each source on the mixing console. Same thing with the speakers. So there's definitely an installation advantage and a troubleshooting advantage if you install an Ethernet-based system. So let's see, who is working on Ethernet? Well, it's the IEEE guys. If you haven't heard of them, the Institute of Electrical and Electronics Engineers. They write the book that tells us what Ethernet is. And they have an AVB task group, the 802.1, and that is going to provide the specifications that will allow time-synchronized, low-latency streaming services through IEEE 802.networks. Okay? Now, that's real important because what they're doing is they are going to take the existing Ethernet network and beef it up. We're going to make it a little bit better, bigger, stronger, faster, so that we can handle time-synchronized and low-latency streaming applications. And I'll just pause here. This is something when I attend, for anybody on the call who may be a BTX member, and I attended the BTX conference, and we were talking about doing video over UTP, and the knee-jerk response I get is, oh my gosh, we've been doing that for years. You can do video over IP. Well, not time synchronized low latency. We're talking live broadcast here. The existing Ethernet standard wasn't quite ratcheted down enough. So why would we want to do this? Let's take a look here. This is a live production environment, and it's all baseband, and what you're looking at is a single cable through a single circuit switch network, and you get high reliability, no delay, instant switching. But I'm not even going to try and talk you through all those lines and dashes. That's a lot going on. There's no central point. There's also, if one line goes down, you don't lose the whole studio, okay? So there's a lot going on there, and you can see why this is a very robust but very expensive way and difficult to manage infrastructure from a traditional standpoint. Let's see what this would look like with AVB. Isn't that much nicer? I'm oversimplifying it, of course, but this is from broadcast engineering, where they were showing the difference between traditional networks and live production using Ethernet. And guys, newsflash, this is a 2008 drawing. So we have been talking about this for quite some time, and I would say, it's still emerging. But what's beautiful about this particular format here, look at the Ethernet switches. You've got single points of management. You can do a lot from one single point. You have a lot of control on this network. So what's it going to take to get us there? What do we really need to get us there? Well, we need to go back to our draft standard. The AVB standard is going to be an addition to the Ethernet standard. I kind of jokingly call it Ethernet 2.0. That's not an official word there, guys, but it's the next big evolution of Ethernet. It will be completely backward compatible with any legacy Ethernet. That's very important. It's also going to improve the performance, okay, so that you can have time-sensitive audio and video data streams on here, okay? The goal is to make sure that we have next to zero latency. Now, it's also been being referred to more recently as time-sensitive networks because it's not just for audio and video. Obviously, I would say the audience on this call, we're pretty prone to only audio and video, and I'm fine if we keep calling it AVB. But don't be thrown off if you hear TSN. The time-sensitive networks is another superset of the AVB, and the guys on the industrial side that are looking for this are calling it TSN. But let's talk about what this means for all those existing audio Ethernets that we looked at. Well, those are proprietary versions. Like I said, even though they might look like a duck and walk like a duck, they're not a duck, and they're not going to be able to, they're often not going to be cross-compatible with Ethernet. But any existing Ethernet network that you have, which are most of our LANs in all commercial buildings, will absolutely be backward compatible. So let's talk about what the exact bells and whistles are here. I'm not going to get too technical here because I only play an engineer at work, but AVB uses several different underlying standards to help eliminate the jitter from the network, okay? That's what we're looking at. What we want to get to, like I said, is zero latency. And the standard is right now set at 2 milliseconds through 7 network hops. And for those of you that may not be as familiar with networking setups, 7 hops is a lot. That is a long way to go. So really dialed down the latency. It also allows for precision time protocol, which is a way that ensures that all the devices are working off the same clock. Any of you broadcast guys out there know about the clocking. It's very important. It helps eliminate the latency. Stream reservation protocol. I like this. Gets a lot of chatter out in the field. The SRP is how we're writing to give the priority to the video and audio streams. Ethernet is deterministic, and when packets come on the network, they're all rushing to use the same bandwidth. What SRP does is it allows us to reserve a portion of the bandwidth to where video will always be front of line. I'm from Orlando, so it's your fast pass. Here you go, video. Now, for those of you that might know anything about bandwidth, you're going to ask, well, Holly, what is the SRP set at? It can be set as high as 75%. Many people are saying it'll be set at 25%. But what does that mean? Let's take the low number. Does that mean 25% of my network is constantly off limits? I'm just going to hold 25% of my tables in the event that video wants to come in and have dinner. Well, not quite. The stream reservation protocol, what is the good part about it is when video is not present on the network, that bandwidth is available. So everybody's humming along. There's no traffic jams. Now, the minute that video says, hey, I want to jump on your network, guess what? 25% is shut off. So while it's available when video is not there, I would offer to you, and again, this is an emerging technology, I'm just one opinion, I would offer to you that in essence, you're saying that I've got to reserve 25%. I've got to have 25% ready at any given time, or the rest of my stuff goes down when video enters the network. So I've seen some conversations out in the field. You know, I get things like, not on my network, or great, you want 25% SRP? Great, you got to double the size of my network. You go talk to the CFO about getting more bandwidth. So it will definitely have to be addressed. But again, some of the benefits once we get there, the low latency, hundreds of audio channels. The actual number of channels is only limited by the bandwidth. You can mix your AVB streams with non-critical data. You can have machine control. And remember, this is not just for audio and video. This is also for anybody that wants to run on AVB. The industrial world, process controls are very, very interested in this. As a matter of fact, one of the founding members of the Avenue Alliance is GM. Think about it. If you can have this, what is more important to have low latency? You know, video. If we lose a video packet, we could lose a job, right? Well, what happens when you use an information packet on a process control line at a factory? Well, everything falls like dominoes, and you have to reset everything, and it can be very costly to set everything back up. So I just kind of made a passing reference to the Avenue Alliance on that logo that I see is covering up part of my presentation. Shame on me. I'll just go ahead and fix that. The Avenue Alliance was put together by manufacturers to address interoperability, okay, to make sure it was founding members are members like Cisco, GM. They want to make sure that there's interoperability, and starting this year, they just started testing different equipment. You can send your equipment to the University of New Hampshire, and they're actually testing for AVB compliance and interoperability so that you and I know that when we buy one piece of equipment from here, put it onto a legacy network, everything's going to talk. It's a very, very good service to the industry. Moving on, we're going to look at this table right here. Remember I said that this is an emerging technology, but I want you to see that this is not brand new. It came on the scene in 2010, and you can see as long ago as September 2011, we'd already ratified the first part of the standard. Up to all the way through April of this year, we have been, the IEEE committee, has been approving different parts of AVB. So it's well along the way, but wait, there's more. These are some of the standards that are still under development, so not quite there. And I would offer to you that while we're pretty far down the line, manufacturers like Cisco, to my knowledge, have still yet to put out a product that's AVB enabled. The audio guys definitely are putting out, there's a lot of big names in audio, are putting out AVB enabled products. So we're starting to see it come. I don't think it's been the watershed moment, has not yet arrived. But one of the things that I love about it is, let's say you did want to deploy some AVB enabled equipment into your network. You can go in and set up VLANs. Now, it's not an upgrade. It's backwards compatible. So you can put in different domains using virtual LANs and set it up with AVB-enabled equipment. And within that node, those nodes, you'll be able to use all the bells and whistles from an AVB network. Now, when it hops outside of that domain, obviously, it doesn't carry all the bells and whistles with it. You lose that functionality. But again, it'll be a nice way that it can be implemented a little bit at a time as the standard continues to evolve. Now, last but not least, I like to throw in here a little PSA. Yeah, I say get ready for a new kind of switch, and that's kind of tongue-in-cheek because these aren't really new. When AVB was first ratified, you started seeing some product come out on the market, and my joke was, hey, you can have any flavor of AVB switch that you want as long as it's 24 port and 19-inch rack mounted. And everybody would laugh, but that was it. That was all that was available. And the switches that I have pictured here actually come from Hirschman Automation. That's a Belden brand. They do mission-critical Ethernet switches. And actually, we have an engineer from Hirschman in Germany that sits on the IEEE board that is writing the spec, one of many. So these switches are already starting to come out aimed at mission-critical applications, factory floor, broadcasters, and different things like that. What you're looking at, I like the two on the left. Those are both Ethernet switches. The one on the very end on the left is an Octopus switch. That is a fully sealed IP67 compliant using power over Ethernet switch. That means you can submerge that switch up to 3 meters in water and it'll still function and deliver PoE. So these are some robust switches. The one second from the left, that's actually an 8-port. You can get that up to 24 ports, and it's probably about a 6-inch cube. It's DIN rail mounted and can be DC or AC powered. So a lot of different options here, and I think as the AVB standard continues to emerge, we're going to see Ethernet deployed in a lot of environments that are not your typical office building. You're going to see AVB being utilized to manage networks even outside of a broadcast studio, maybe in broadcast trucks, maybe in theme parks, security, different perimeter type Ethernet applications where you might need something that's harsh for harsh environments. So get ready. It's not going to be just your typical old, like I said, 19-inch rack mount switch. So that was Ethernet. Now I want to switch, and we're going to talk about HDBaseT. And the question I get most often is, well, isn't that just Ethernet? Short answer is no. But since I still got, another 30 minutes here, we're going to talk a lot more about it. Let's first start talking about where HDBaseT came from. HDBaseT came from HDMI. Sorta. So follow me here. HDMI made it on the scene in 2003. It was a new way to deliver high-definition multimedia interface. Basically, what I saw in my home is I went from having a coax cable come from the cable provider to the back of my TV, and last time I checked, guys, my CATV only had 2 conductors, the center stinger and the shield. And now they want me to use this 19-conductor HDMI interface, and boy, it sure seems a lot more confusing and harder, and boy, it was a lot more expensive. But it did deliver high definition, and that's pretty cool. I like that. But even more importantly, it had HDCP compliance. For those of you that don't know that, that's high bandwidth digital content protection. The race continues to stop pirating and to protect our products. And make no mistake about it, HDMI was developed by the studios and the manufacturers to enable, to have a way to protect their content. Okay? And that's fine. But everything I've told you so far is home-centric. This is a technology that was absolutely originated in the home. Okay? HDMI is used to go from the back of my television set to my DVR now. Okay? It wasn't a commercial or something that we would use in the workplace. So what happens when I want to run it further than the standard distance? And I know this will probably be rhetorical, but what is the distance limitation on HDMI? How far can I run an HDMI cable? No, it's a trick question because there is no specified maximum length on an HDMI cable. Basically, for those of you who are integrators out there, you know this. You run it till it doesn't work, and then you figure out how far that was. We see the industry accept it at around 30, 25 feet. I've heard some folks run it as much as 50, but it becomes problematic. And good luck finding a plenum HDMI cable if you actually want to run it in a building plenum. So this is decidedly a consumer-based technology that is coming into our workplace. And make no mistake about it, it is coming on strong. Unlike the slow migration that AVB is having right now, in 10 years, there are over 3 billion HDMI devices. That's a tidal wave, guys. So let's see what it actually is doing. HDBaseT, introduced just 3 years ago, is a way to use a single LAN cable to replace multiple connectors in the home entertainment and the business environment. Okay, HDBaseT is talking to me because they want to help me with this problem I have. I want to deploy 30 displays in my conference rooms and have them all come back to a central point, and I don't have enough HDMI cables, and I don't know how to get all those in my conduit. So they're going to help me do it. Let's see how we do it. Okay, here's the HDBaseT. I know this is a very busy slide here, and I've taken it from the HDBaseT Alliance, hdbaseT.org. It's pretty cool. It's a consumer electronic connectivity technology. Basically what you're looking at, on the left we can have our source, on the right we have our display. You still have all the HDMI cables, at the local area, but in the middle we're running an over 100-meter LAN link. Now, for anybody who's done anything in commercial buildings, 100 meters is the standard that TIA puts out there for all the Ethernet links. You truly have millions of these connections in any commercial building that you go into. So the HDBaseT is telling me that I can hop on that what was previously an Ethernet link, put on my HDBaseT equipment, use that pathway, and run my HDMI signal. Clear as mud? It's actually really cool. It's a way that I can extend, rather than going 30 feet or 50 feet, I can go 100 meters, 328 feet. So really cool technology. I like it. But wait, there's more. HDBaseT coined and trademarked the term 5-play. On that single LAN cable, they're going to run full HD video, audio, Ethernet, control, and power. Power is my favorite thing to talk about because I think it's still the most unsettled right now, or underutilized, we'll say, part of the 5-play. They're saying that they're going to enable power up to 100 watts. Very exciting stuff happens when you can do that. So let's see what else we've got. Whoops, a little over a month ago, HDBaseT released their 2.0. Okay, and the HDBaseT 2.0 is when I first looked at it, it looked to me like, wow, it's introducing the home play feature set. Again, remember that HDMI and HDBaseT, consumer-based. The home play feature set gives the consumer version a lot of different bells and whistles that was only available previously in the professional version. It also shortens the limit. Rather than 100 meters, 328 feet, you're going about 230 feet, which for most homeowners is fine. But it does add network switching and control point capabilities. This to me is very exciting for the commercial world because you now have point to multi-point connectivity. Now we're getting into something that we're more used to, where we can run all the cables into one central point and operate all our different displays or different devices throughout a campus. It also has some inherent support for the USB 2.0 and other interfaces, and it allows the manufacturers to remove multiple interfaces. Now, don't get this confused, as I did when I was researching this, with HDMI 2.0. I was reading in Consumer Pro that many of the integrators still haven't overcome the headache from the HDMI Rev 2.0. A lot of different interoperability problems there. HDBaseT right now has one chipset manufacturer, Valens. And Valens, one would assume that if I've got one chipset, I'm going to have interoperability. And they are now currently testing for interoperability between the different HDBaseT-like devices. But that was the hottest question at InfoComm in June, was, are these interoperable? So that's what HDBaseT is. It allows you to take that HDMI type connections and deploy them into the workplace or into longer runs, multiple runs. So a question now, I pulled this from their website, frequently asked questions. Yeah.
I'm sorry, I'm going to just stop you before you go any further. We have a few questions if you don't mind answering a couple.
Sure.
Before it gets too far off base. I think if you go to the slide before this one, somebody asked if you could go longer on Cat 6A.
It is not defined in the standards, so I'm going to say no.
Okay.
Hypothetically, you could, if the signal integrity maintains, I could tell you in the Ethernet world, with a good infrastructure, you can take Ethernet farther than the 100 meters. But as defined by the standard and what all of the manufacturers are building to is the 100 meters. So I guess the answer is you might be able to, but you're on your own.
So then another question that came in, can we send a tri-level sync signal over HDBaseT?
I do not know the answer to that. Again, HDBaseT is the brains behind converting the HDMI and running it over the 4-pair. You know, from a cable manufacturer standpoint, you can run a lot of things over UTP. I'd have to look into that.
Okay, we can come back. What is the best way to verify and certify an HDBaseT cable run?
Ooh, you're getting ahead of me. Belden is working on a certification program right now. It's not been launched, but you're going to see in some of our testing, we're proposing ACMC type reading that I can get into more detail. I'm not going to lie, I don't know exactly what our warranty or our testing requirements will be at this point, but we are working on it, and to my knowledge, I don't know that anyone else is. It seems that the current method is, you know, plug and pray.
Lovely. Okay, so the next one, and I think this is the last question that we'll take, is shielded versus unshielded cable in the HDBaseT spec? Question mark. Is it in the?
I have not found it in there right now. That's a great question to go back to where we were. Are there any special cabling or connector requirements? And they will tell you no. You can use any existing Cat 5e or Cat 6 LAN cables. We do have the latest version. I want to say it was over, because Belden is part of the HDBaseT Alliance, and I want to say it was over 900 pages, and shame on me, in full disclosure, I have not read it. So to my knowledge right now, they are still, and I did check this yesterday on their website, they are still saying any existing Cat 5e or Cat 6 installation. And in the United States, you will find 98% of the time it's going to be an unshielded LAN. The government is known to use shielding in some instances, but I would say on those networks you're not going to be allowed to run your HDBaseT. They've got other stuff going on. So right now they've not addressed it.
All right, very good. Holly, thank you very much for answering the questions. I'll let you go on with the show.
Perfect, perfect. So this is a great point to say, well, is that true? Does that work? Short answer is, yeah. I can run one signal over one cable, and it works just fine on a Cat 5e. And if something fails, tons of information out there about how to set up and properly set up the source and the display, getting your deep color and all your EDID tables. But there's essentially only 3 points. If your AV professional has properly set up the source and the display, and you're not getting a picture, the only other possible point of failure is everything in between. So if all my settings are correct, what's wrong with the cable? And this is what was happening in our travels with the broadcast specialists at Belden. We're getting cases from the field where they're saying that the signals and separate cables that share the same pathway, they think they're interfering. There's causing a lot of drop links or a degraded picture. I'll tell you guys in full disclosure, one of the manufacturers that we work with, and you know, Belden's been around a long time. We work with a lot of manufacturers of equipment. Kept requesting a 100-meter patch cable. So we made it, sent it out. Okay, odd request, and we need some more. We need a whole bunch of them. So if you're like me, you've got to ask, what on earth are you using these 100-meter patch cables for? And it was from a troubleshooting department of a major manufacturer. He said, well, look, we're getting these reports of out-of-box failures and dropped links, and we know our boxes are good, so we have the customer unplug the devices and then use this 100-meter patch cord to connect it because we got it from you guys at Belden. We know it's good, and if it works, well, then it's the installed cable. If it doesn't work, then we address the boxes. So it's kind of a pretty good way to troubleshoot out in the field. Not terribly efficient. So what we proposed was, how about you send your equipment to Belden, and we can perform a controlled set of tests. It's a lot easier for Belden at our factory. We use the lab in Montreal to test several different scenarios. But you send us the equipment, and we'll test it 6 ways to Sunday and see what we can find out. And that's what happened. And just for the parameters of this test, we tested at least 5 different manufacturers. It was not just a one and done. We set up a standardized test, and in the cabling world, this is a pretty common scenario. We're using the 6-on-1, and what you see there is we're using a bundled cable, and we create a victim cable. Geometrically, you can only get 6 cables touching that 7th cable. We light up all 7 cables, and we perform the tests on the one in the center. So we try to make it as just horrible as possible. We're going to generate a common video signal, run it through the switcher, test it on the output. And for the purposes of this test, when we didn't have a picture, it was considered a failure. I would think everybody's in touch with that, right? So now what different scenarios did we test? Well, the first one we tested we'll call the 2-connector test. Not terribly common in AV-only installations, but this is what you're going to see in just about any LAN in America or North America, where you're going to have rack to jack. You're going to go from a jack to a jack and then use a patch panel into your equipment and your display. Okay, so essentially 4 connections. I would offer to you that historically this has not been terribly popular in the AV world for several reasons. One, remember back I said AV didn't used to be permanent. We weren't using permanent links. B, with all the different signals running on different cables, as a professional, you wanted to mitigate the points of failure. I want as few termination points as possible because I don't want to have to troubleshoot all of those different connections. And then finally, a lot of the traditional AV guys, I don't want to put my cabling into a patch panel and run the risk that the IT intern is going to come in and accidentally unplug it. I want to make sure that I'm segregated. But this 2-connector scenario is your typical LAN installation that you're going to find that HDBaseT can run on. Second scenario that we tested is preterm. This is taken off especially in data centers, where instead of having a punch-down jack, you're plugging into a coupler. Again, you've got several points of termination there, so several potential points of failure. The last scenario that we tested is direct attach. This is what many AV professionals are used to using out there. You put an RJ45, an 8-position modular plug on each end of the 4-pair, and off you go. So we took this, and we are going to perform an ACMC test. Now, ACMC is the Alien Crosstalk Margin Computation. Again, when you look at the HDBaseT scenario and typical installations, it's a single cable. Again, I would offer that that's probably because it's a consumer-based technology. When you came into the workplace, the reports from the field are when we had multiple cables bundled together, we were getting failures. Now, alien crosstalk, for those of you that are been in the business out there, crosstalk is when 2 wires within a cable share signal. So back in the old day when you had the telephone operator and you actually hear people talking because your wire crossed another person's wire. Alien crosstalk is when a signal jumps from one cable to another cable. So a little bit more serious and a little bit harder to define. But no worries. Back in 2006, when the Category 6A standard was emerging and making its way into the LAN world, That's the 10 gig. Actually, the lead engineer who wrote the white paper on this presentation that I'm giving you now, Paul Kish, was one of the engineers that developed this set of tests. ACMC is a way to combine a bunch of different electrical measurements and express them as one number. Okay, so they're looking at power sum, near-end crosstalk, far-end crosstalk, and in its test we used a Fluke BTX 1800. Nothing, no smoke and mirrors here, and we tested that. Now, what we did was set up our different transmitters, receivers. You can see in the background several different scenarios. No smoke and mirrors here. We're just putting in the information and then churning it out. And then this is to show you that we are not photographers. This is a real working lab here. And these aren't golden reels of cable. These are cables that are meant to emulate a real-world installation. You can see that cable tray is pretty loaded up. So once we got everything in there, again, proof of concept, here's what we did. We went from anywhere from 10 to 105 meters. And here is what we'll call the sum of the evils. What you're looking at here, guys, is a compilation, a couple of points on the different scenarios. We did not see a significant difference. It was statistically insignificant between a direct attached, pre-terminated through the couplers, or the two connector scenario. So, you know, working in both the data and the AV world, that made me feel really good. So that if an AV professional is forced to go into a standard LAN type environment, there's no worries. When you're running HDBaseT, it's going to work. It's going to work the same in a direct attach as it would through a patch panel if that's the scenario you have to go through. Now for the bad news, you'll see that through the different scenarios, anything that had an ACMC reading of -3 or more failed consistently. Anything with positive 3 dB of ACMC passed consistently. Everything in between, kind of touch and go. That little area of uncertainty there in the middle, I would say a lot of us are working in that area. And that's an area, back to an earlier question, well, you know, can I run it over 100 meters? Well, yeah, but you know, you might be impacting your ACMC. Can I run it on unshielded cable? Yeah, you might be impacting it. But if you have +3 dB on your ACMC computation, okay, reading, you can say, yes, that's going to run HDBaseT. Now, let's look at who actually got that +3 dB. This chart, I had them put it together to compile everything. Remember I told you that the 3 different scenarios, whether it was direct attach, coupled together, or the 2 connector system, I didn't list each one of them unless you can see, like in the Cat 6, we had a slight difference between field terminated and pre-terminated. But let's just start at the top here. Category 5E UTP unshielded twisted pair. You can see that on a standard Cat 5E unshielded, it ran 10 meters. For those of you that weren't raised on the metric system like me, that's 32 feet. Well, if I'm going to run 30 feet, why bother converting it to HDBaseT? I'll just use an HDMI cable. Okay, after that it failed. So then we tested it using a shielded, because again, shielding can help mitigate alien crosstalk. Boom! It passed all the way out to 105 meters. Same thing with Cat 6. Cat 6, unshielded twisted pair, you could get about 30 to 40 meters. Cat 6, this is an earlier question. Cat 6, because of its construction, when we went from Cat 5e to Cat 6, we went from running 100 megahertz to 250 megahertz. So the cables, physicals, and electricals are different. It's twisted a little tighter. It uses a slightly larger gauge size wire. So it's going to be a little bit better cable. So that's how you got a little bit further than the 10 meters. In a Cat 6, you could get out to, like I said, between 30 and 40. Is that enough to justify hopping to Cat 6? I would say no. Cat 6 shielded, boom, 105 meters. So you see the trend here, guys. You got to use shielded cable. But wait, when we use the Cat 6A, Now remember, Cat 6A was developed in 2003, 2006. It was specifically deployed to run 10 gigs. Okay? This was a time when we had to develop the ACMC computation to identify and mitigate the alien crosstalk problem. Cat 6A with an HDBaseT application worked out of the gate unshielded. So Cat 6A, I could do it in any configuration, shielded or unshielded, and it passed. And to many people, that's not terribly surprising because, like I said, the Cat 6A was developed and had to overcome the alien crosstalk that would happen on the higher speed applications when you got out to 10 gigs. Now, the last little disclaimer that I put down there, remember, and there's nobody that can talk shielding more than Belden. Shielded cables rely on the integrity of the shield and a low impedance path to ground. And I got to tell you, no matter what environment I'm in, whether it's industrial, data, AV broadcast, grounding and bonding continue to be a hot topic. If you don't ground that sucker properly, you've just created a bigger problem than you're trying to solve. So again, I would say this is why the #1 recommendation is going to be to use a Cat 6A. If you have the option on a new installation, using a Cat 6A unshielded twisted pair, out of the gate you're okay. You do not have to worry about grounding the shield. And you also, by the way, will have the most up-to-date installation for any kind of LAN applications that you have. If you're not going to use that, or if the cost isn't justified, you can go to a Cat 6, but use shielded, guys, or you're going to have some serious distance issues. And again, it could be something as simple as how many cables are in the bundle, what it's running near, how it's being supported. You're going to want that to be shielded. And then last but not least, we want to make sure that you know when you're installing those systems, it is vitally important to maintain the integrity of that shield, both with shielded 8-position modular plugs or jacks in your patch panel, whatever you're doing. Now, in Belden terms, for those of you that are interested, Cat 6A, those are the part numbers there. The 10GX12 for the riser, 10GX13 for plenum. We do also make shielded. I would offer to you it's not terribly necessary, but some manufacturers, that's another thing. We talked about AVB versus HDBaseT. AVB is an Ethernet-based standard that is absolutely going to be open. HDBaseT is not Ethernet, but HDBaseT will let you run different kinds of equipment. But beware, the equipment manufacturers are basically using an HDBaseT platform, but some of them put in, I'm going to call them bells and whistles, some different feature sets that are outside of the HDBaseT world, and that then makes their highway proprietary. Some manufacturers are running a signal on that shield, so if you drop the shield out, you're going to lose that functionality. So always be aware of what manufacturers' requirements are. But I would say as an industry, I'm encouraging the folks I talk with, HDBaseT is a standard that's pretty well adopted out there. This is going to work for HDBaseT. It should work with any equipment that you buy. Cat 6 cable, we recommend Belden's 2412F, or 2413F, that's plenum and riser, both shielded, only recommend shielded. Same thing on category 5E, we only recommend our 1212, 1213 shielded cables. Now, if you want to read more about this or just see more, you can go to our website and check out our white paper, HDBaseT over bundled cables. And I've added a new one in here because if you remember, early on in the presentation, I talked about running power. Power to me is so cool in this application. The eventual state that HDBaseT sees for their application is that you're going to run directly from your source over a category 5E or category 6 or 6A cable directly to a device. Let's take a display. And you're going to plug that RJ45 directly into the display, and that's it. I know that a couple of manufacturers, Planar is the one that comes to mind, has them already. And you can run up to 100 watts of power directly into that display. Now think of the advantages. Way fewer cables. For those of you familiar with OSHA and ADA compliance records, any display that's mounted less than 86 inches off the ground can't extend more than 4 inches from the wall. What's an easy way to make that screen skinny and sexy? Remove the power element. Put it back in the closet with all of the equipment. Run a single cable to it. It's a very, I think it's a very alluring prospect, and I think we'll see more and more out there. Now, with that said, something that's been a hot topic in the data center side of the world is the heating effects when you have remote power delivery. This is another white paper you'll find in the same resource center on the Belden website. It gets pretty techy. I've made it through it twice, and you just got to be mindful. I think this will be the next technology that we'll be addressing. And when we do start running a lot of power over these twisted pairs, we're not dropping signal, but we're seeing, 10 degrees centigrade increase in our pathway. And that's a concern for the building owner. So just kind of a fun little future state to look out to there. And with that, I am finished.
Holly, thank you so very much. I want to encourage everybody to answer any, or to ask any last-minute questions. Of course, all of the different Belden solutions that you saw, you could certainly get through BTX. Rose, do you have anything you'd like to add?
Yep.
Nope.
Good job, Holly.
Good job,
and,
Holly.
Whoever asked the question about tri-level sinks, we'll look into that.
Did we capture
I know
that?
that's a way of delivering HD to television, Holly. So I'm thinking that it probably does work, but we'll have to look into it to confirm.
All right. Well, with that, I think we're going to conclude this webinar. Thank you again, everybody, for spending the last hour with Belden and BTX. We certainly appreciate it. Thanks, Holly and Rose. Bye, everybody.